right, so going over the test. The first, nobody got every single question right, but there were a few pretty high scores, and nobody failed the test. So the first question was, on a dot density map, which dot density goal should you try to achieve for statistical areas at the highest and lowest ends of the range? In your answer, state 2 adjustments that you can make as a cartographer to the dots to satisfy those goals. So there's some people that answered this question very succinctly, and they still got full credit. So it's basically worth 3 points. So all you had to do was say, 4 points. So all you had to do is say, in the most sparse areas, you want the points to be, you want there to at least be 2 or 3 points. In the most dense areas, you want the points just to start to touch or coalesce. And then the adjustments you can make are to the dot size and to the dot value. And I tried to give credit if somebody said something that meant that, but you know, if I didn't understand it, sometimes I gave partial credit. But anyway, yeah, that was worth 4. All right, on number 2. On a dot density map, what problems might you encounter while assigning a dot value for a phenomenon with a very large data range? And here, in some ways you could argue that this was asking the very first part of the last question again, but what I was looking for here is that the map may not have any points in the lowest populated area, or it may look too crowded in the most dense area. So that's what I was looking for to get full credit. All right, number 3. Why should your enumeration, that was worth 2 points, by the way. 2 points. Why should your enumeration unit be as small as possible when creating a dot density map? And so the answer that I was looking for here was that since the dots are supposed to represent the true, or at least the kind of the center of the dots that they represent, they're spatial proxies is the term that we use in the course. Since they're supposed to represent that location, confining them to the smallest geographic unit possible will allow them to be as close to their true location as possible. That one was also, that was just worth 1 point. In dot density mapping, I did leave the key, so sometimes I may be wrong, but I'm pretty sure that was worth 1 point. In dot density mapping, define what is meant by a locational filter. All right, this one's also worth 1 point. A filter allows us, sorry, I started reading somebody's answer, but it is correct answer. The filter, like this was the key or something, but the filter restricts where dots can be placed. So it's a layer that says, okay, don't place any of the dots in these locations, because there's no possible way that the subject being represented by the map, it might be people, can exist in these locations. So just exclude these locations. Okay, the next one is define spatial proxy as it relates to cartography. And the spatial proxy is, this one was worth 2 points. The last one was, I'm pretty sure, worth 1. Spatial proxy, the reason why I made this worth 2 is because I had to give lots of partial credit. A spatial proxy is a feature that represents a number or a group of entities, and you're trying to place it in a location that represents those entities. You're trying to represent where they are, even though the location's kind of fuzzy or not precise. You're still trying to represent. So it's different like then sometimes in a proportional point symbol map, you put the dot in the middle. Well, you usually put the dot in the middle of the polygon feature. You're trying to represent the true location, whereas in a dot density map you are trying to represent. And it's also different than a proportional point symbol where you put the dot exactly at the location of that particular feature. Anyway, in a dot density map, what is the disadvantage of drawing the enumeration unit area borders at the same level as the dots? In other words, why shouldn't you do this? Basically, it gives the user, the map reader, the impression that the map is more precise than it is. Because those dots are spatial proxies, you don't want to have the boundaries because it enforces the location and helps people have more of a reference. You want to like leave it fuzzy on purpose. That was the best answer. I should have also given partial credit, so this one was worth 2. If you said that it would make the map look too busy or too crowded, something like that, because that's also true. I mean, when you have that many dots on your map, you don't want to have the lines usually. Okay. Oh, this isn't proper English. When creating a proportional point symbol, what are appropriate symbol shapes? Why? And typically, these should be regular polygons. Usually, circles would be the best. Squares would be the second best. Triangles would be the third best. That's what we said in class. So if you said that, you were correct. Why? Anything that's more irregular than one of those regular shapes, it's really hard for people to judge size, and that's the point of a proportional point symbol map, is to judge relative sizes. So you don't want to use irregular symbols unless they're like there's a few rules. Like if you only had a few of them, and it was anyway. That was what we said for the test. All right. What is the Flannery method, and why is it used? So full credit here, by the way, the last one was worth 2. Full credit here was that it is an apparent scaling method for map symbols. Full credit. You could have just said that. If you said something similar to that, you should have gotten full credit. And that is the answer. Number 9, give an example of a case. Oh, before I go on, just in case somebody here doesn't understand a parent scaling method, like what if you put, it's a method for scaling dots. Well, you get partial credit for that, or methods for scaling shapes. You had to say that it scales shapes, and even if you didn't use the word apparent, that it scales shapes to be slightly larger than they should be because of the way we perceive the dot. Okay, 2 points. Give an example of a case which you would not want to use proportional point symbol mapping techniques. Here, I was looking for an example. Sorry, I was not looking for an example of a specific case. So I did give partial credit when those specific cases were correct. I was looking for, a rule saying, okay, well, we shouldn't use proportional point symbols in these type of maps from your book. So if the range was really small or really large, but like if you gave a specific example, said we wouldn't want to use it to map pig populations or something like that. I mean, I don't know that pig populations would necessarily be a bad choice. I'd have to know more about the map type you were making and whether you were normalizing it or leaving it as totals. So whether it was derived data or total data to give you full credit. All right, number 10. The lines on an isorhythmic map represent what? Here, I gave you full credit if you said that the lines represented an area, or sorry, a linear range of constant values. Everywhere along the line had the same value. Now, if you said they represented elevation or temperature or something, yes, they do represent that, but in general terms, that's what I was looking for, not a specific example again. So I did give partial credit for a specific example, but you needed to say for full credit that they all represent, everywhere along that line represents the same constant value. I had some people actually explain that it was kind of like passing planes through the surface, which was also a fine answer. Okay, number 11, so that was worth 2 points. Describe the difference between isometric and isoplathic maps. This was worth 3 points. In which case is mapping totals not derived values appropriate? So the difference here is that it's the data sources. Isometric maps come from point data or derived from point data. And so since they're derived from raw point data, not aggregated to areas around that, totals are okay. Choropleth maps, isopleth maps, just like choropleth maps, are derived from an area. They need to be normalized, just like choropleth maps. So you need derived data. Your data needs to be derived to use that type of data. So isoplathic was derived, isometric was totals, and so that one was worth 3 points. So basically you needed to define isometric, isoplathic, and then say that isometric was the totals. All right. So some of you might have a number on the top right at this point. Some of you might not, just depending on when I graded your test. I started, at some point I switched over to like grading all the multiple choice first because it was really quick to grade that part. And just don't pay any attention to that number. It's just the number of multiple choice questions that you missed if it's there. Okay. So number 12, I considered that a multiple choice question. So maybe I should have put that below. So that one was the one on the left, the one with the ISO lines above the county boundary lines. And that was very similar to a picture from your book and that we showed in class on a slide. But you always, we actually reinforced this since the test, you always want the thematic map symbol to be the highest element in the visual hierarchy and on top. Okay, so that's why number 12, the first answer, I didn't label it, but if I did label it, it would be A. Okay, going back to non-multiple choice questions, those are proportional point symbol maps. You should have received extra, like a +1, if you not only said that those were proportional point symbol maps, but you said that they were I'm having a blank moment here, but if you said that the points weren't actually they're graduated symbol maps specifically, because they're not they can only fall into a few different sizes for their shapes. So if I missed it, if you said that they're graduated symbol maps, you should have gotten a +1. Proportional point symbol maps, you got full credit. That's why I said be specific, but not necessarily lengthy. And then if you said something like dot density maps, or I don't know why you'd say anything else, but that's wrong because it's not a dot density map. Now the one on the left is the one that's better, so that was another point. And the reason why it's better was that it is symbols, so it's kind of like re-asking that other question, but because it's a regular shaped symbol and not a car shape. All right. So let's go on to the rest of the multiple choice questions. Okay, circle the letter you feel is the best answer. Now, I guess with those instructions, you could say, well, I feel that's the best answer. I did circle the, how come I get it wrong? It's the one anyway. I should say, you still have to answer it correctly. 14, an undirected or non-directional flow map lacks B, arrows or visual cues representing the direction of the flow. 15, what of the following, so that's pretty straightforward. I'm not going to explain it. 15, what of the following choices would be the most inappropriate method of symbolizing a qualitative, that's the key word in this question, difference in two lines on a flow map. And class and the book actually emphasizes this as well. In a qualitative flow map where you're not distinguishing the amount of flow, it's important not to change the line thickness because line thickness is almost always interpreted as an amount of flow on there. So A is the correct answer. The most inappropriate method. You can change the color, you can change the pattern, you can change the lightness, but don't change the line thickness. All right, number 16. Which of these represents redundant coding on a flow map? Redundant coding means that we're trying to say two things. Like we might be trying to say the flow in terms of the amount of goods. We might be saying whether or not it's going in or out. Or we might be trying to say whether it's services or goods that are traveling. And we might color services one color and goods another, and then use the size to represent the amount. So the correct answer is a change in both line thickness and lightness value as flow increases. Now we could say color, but that's not an option, so that would have been correct as well. But that's not an answer. I mean, it is part of A, but we need two choices in the answer for it to be correct. So C is the correct answer there. The most correct answer. 17. The map below will fit into which flow map category? This is a network flow map, B. Okay, it's not radial because it doesn't radiate out from single points. It's not distributive because first of all, we're not talking about actually like the flow of things away. We're just talking about car traffic. We don't even know which way it was going here, so it is undirected. It's a network flow map. It's basically showing the flow between connections. All right, B is correct. The next one, 18, the map below would best fit into which map category? Flow map category, that's A, radial. It's not network. It's not distributive because the lines don't, like number 19 is an example of a distributive map, the little example in 19. It's not distributed because all the lines just connect locations. All right, 19. The correct answer is D. What's wrong with the subset of a line from a flow map? When the line splits, the entire line thickness does not carry forward. Okay, there's a little piece of it that you're like, what happened to that? Did that just like get lost in the move or something? That's the problem with that one. Number 20. Which of these examples is a better way to symbolize lines on a flow map? That's A. It's similar to the proportional point symbol map thing. You always place the smaller item. When they're both thematic elements, you place the smaller item on top, and ideally you use the a lighter color to interrupt it, like it's been done. So it appears to be on top of it. Number 21, it's appropriate to map totals on a cartogram. It is. True. Number 22, since cartograms map areas, it is appropriate to map items normalized by area using this technique. False. You don't want to map items normalized to area, otherwise you're just going to get a map of that thing to begin with because the cartogram itself represents area. 23. Which of the following was discussed and an advantage of as an advantage, should say as an advantage. As an advantage of cartograms. All right, basically I just copied the list of the things that were disadvantages. So all those are disadvantages. Readers don't like them, they may be confused, and the specific locations are difficult to identify, they shock the readers. Those are all listed as disadvantages. So the correct answer is E, none of the above. Number 24. Which data characteristics would make mapping using a cartogram not appropriate? Here again, these were all the things from the list. So in this case, it would be all above. All of those things would make a cartogram not appropriate. Anything correlated with area, if you've got 0 values, you won't have a particular location, and if you have very large ranges in your data, it'll be hard to do. A counting unit is a uniform area on paper that represents a certain number of the variable being mapped in a cartogram. That's the correct answer. Number 26. It's an example of a visual cue that a cartographer might use to communicate information to a map user when creating a cartogram. And we went over all of these. So preserving the area is a good thing to do. If you don't preserve the area, like if you use all boxes, you might, location. If you don't preserve all the shapes, you can use an inset or an area map, and you can also try to preserve the shape itself. People will understand, particularly if they're familiar with the shapes, like if it was in the United States. And then, so D is the correct answer. All right, so again, part of the reason that we go over those tests is so that you can understand them, but also, in case I graded something incorrectly, I took 1 point off for each of the multiple choices, by the way. So if I graded something incorrectly, I didn't use a Scantron form, so I could have even graded the multiple choice incorrectly. Then come talk to me, or email me, or whatever. All right. Okay. So I think